Now we have to start with start FHRP first. STP is basically L2 redundancy protocol.
हाँ, redundancy, right, correct.
So basically क्या है ना, अभी दो केबल डालेंगे ना हम, ये केबल से लूप क्लिक करेगा, to avoid the loop we will block one cable, right?
हाँ.
So it put the tree on the redundant links, correct?
Correct.
By that it will secure, it will not make that any loops, correct? Avoid the loops, it will create it will block the redundant links, correct? वो STP है. Now we are going to study FHRP full form है. Another name is router protocol. Now what is this protocol is L3 redundancy protocol. For example, in your office you want to go to internet. So to go to internet, there is a PC, and in the PC you have connected to a switch. L3 means router, you know, right? L2 is
yes.
Correct ना? I want to have same way. मुझे L3 में redundancy चाहिए. L3 मतलब router में. So then I will put two routers. One router fails ना, I can send the data in another router. तो मुझे internet जाना है. I want to go to internet. One I went to an ISP. Example ISP एक ISP बोलिए. Through which ISP we went? Okay, you are going through Airtel. Okay. Now if you are going through Airtel, right? If you are going through Airtel, you have connected to the router to Airtel. This is my ISP one. This is primary link, primary connectivity. Okay. Now you are connected through Airtel to internet, and you are connecting to Airtel network. Now I want redundancy in this. For example, your router one fails in the company. Do you have any backup? Right? So I want to create a backup redundant in L3 level, router level.
Okay.
So I am going for another router. I connected this also. Now I can go with same ISP, but I can buy another ISP also. So why you need to go with same ISP? I will go another ISP. So another ISP is which is the other ISP you have. So just take another ISP and connecting to the router. That ISP connected to internet. What all the problems will come whenever you connect one more router like this. Okay. Now we saw the problems in L2, right? What is the problem? Broadcast from bridging loop, right? That was the problem, right?
Right.
Same way, when I connect two routers like this, redundant router, primary, secondary, right? What all the problems will come? Like for example, we give some name like active standby. This is active, this is standby. Backup. Backup we call it a standby. So now I'm going to explain you what all the problems will come and how this protocol is going to solve the problem. This protocol, FHRP. Right? So let us write down the problem. To understand the problems, I'm going to use one analogy. This is called ice cream analogy. What analogy?
So we get I mean it will be tasting
okay. काम क्या करेगा?
So the ice cream would be right after taking
the ice cream will have give cold, no? Cold,
right. The taste also.
Same way if you drink also, you know the functions, right? Now these three flavors let us write down. So like this. Now this is the idea, analogy. Now let us put the FHRP in this. So FHRP is like ice cream. Strawberry is equal to VRRP. Chocolate equal to GLBP. Are the three flavors of FHRP. Understand? Their function is same. Functions are same. Like you take any flavor, any ice cream you take, the function is same, right? But three flavors. So what is the flavor is? FHRP full form is the command VRRP is something like virtual. GLBP is gateway load balancing. Cisco protocol is proprietary is this two. VRRP is open standard. You can use in any protocols. VRRP is also active standby, but that name is something they give different name. That is active passive. Understand? The difference here is it is open standard, that is Cisco proprietary. GLBP is different. GLBP is both routers are active. You are sending 10 packets means whenever Airtel fail होगा ना, वो टाइम पे मैं वोडाफोन से डेटा जाएगा तो वेस्ट हो गया ना पैसा. दो लिंक खरीदा हूँ, बट एक लिंक यूज नहीं कर रहा हूँ, स्टैंड पे है. So उसको शेयर करना है, लोड शेयर करना है, मतलब we'll go for GLBP. Okay. Now what are the three functions I'm going to teach you? Okay. Now if you take a PC here, my IP address is 10.100/24. Which interface I will go to internet, correct?
Right.
I will go to WAN 192.168.10.1, for example. This is R1. My router gigabit interface is R1 means this gig is R1. Whenever this PC wants to go to internet, it will go through SW1 then router R1 gigabit interface. Then it will go to R1. R1 will send it to ISP1. From ISP1 it will go to internet. So this is one the primary route. Now what will happen if R1 fails? You have to go to route PC1, change the default gateway to manually. हमको क्या करना पड़ेगा? एक बार PCs में जाकर उसका default gateway change करना पड़ेगा. हम extra router डाल दिया, तो वो router में data जाने के लिए हमको PCs में जाकर default gateway change करना पड़ेगा. अब एक दो पीसी में हो जाएगा, बट 100 पीसी है, एक से 150 200 पीसी 200 पीसी है, मतलब डिफिकल्ट होगा, राइट? समझ में आ रहा है ना? एक पीसी में हम कर लेंगे.
अंडरस्टूड.
तो क्या होगा? सो द फर्स्ट सॉल्यूशन और द फर्स्ट फंक्शन ऑफ FHRP is, then what I will do, I will remove this in all the PCs. Default gateway what I will give? I will give not 1 or 2. I will give .3. Now what is now the PC will do? PC will say, boss, if you want to go to internet, go to .3, 10.3. Now data will go to HSRP. HSRP will send to R1. If R1 fails, HSRP will send it to R2. IP address, MAC address is 1111. So this is the MAC address, okay? It will be there. Now, for example, you change the IP to .2, but the MAC address table will take time to change this 300 seconds. How many seconds? To refresh it. Remove the entry, again it will check. Again check to the entry, .3. For example, .3 if you put, right? If you send again, the MAC address table will not change for 300 seconds. So 300 seconds, the data will keep on going to MAC address will be 1111 only, destination MAC. Okay. So what is the problem here? It will not go. Okay. To solve this issue, what HSRP does is, second function is, it will give you virtual MAC also. MAC address also, virtual MAC address will give. There is a fixed reserved MAC address available. It is reserved for only for this. They have purchased it. Who? Cisco. So Cisco has purchased these MAC addresses. So they will configure that MAC address. Where? To that virtual IP. The virtual IP will have its own virtual MAC also. You understand? What is the purpose of HSRP? Whenever primary fails, secondary has to work. Correct? So this is active standby. Whenever active fails, standby has to come up. Correct? No?
Correct.
To do this, what HSRP will do is, HSRP will send something called hello packet. It will change the state from standby to what? So how the router will change to active? It will keep on receiving hello. Whenever hello is not received, for 10 seconds it will wait. 10 seconds is not getting hello, what it will do?
Yes.
Whenever the primary router, the active router fails, right? It will understand that it is failed by using the hello packets. Now, this hello packet, you can tune it. For example, there is a commands are available. For understanding sake, I can make it 3 seconds also. I can make it hello for 1 second. Hello for 1 second, every 1 second send a hello. And 3 seconds, if you don't get hello, I can make it active. So faster. What I'm giving is standard values, default values. You can change it always. Okay? You understood the mechanism, right? How the standby router becomes active.
So one question here. So basically,
if you don't want redundancy, means you remove that R2. But if you have a R2, then R1 and R2 has something link has to be there, no? Something has to happen, right? The protocol. That's why remember I told you static routing, dynamic routing. When we go for dynamic, when we don't want dynamic routing is, you don't want to do any bandwidth consumption, right? So then now the idea is what? I want to have a redundant link, redundant router. Whenever primary router fails, automatically redundant has to come up, right? Whenever you configure a protocol, any protocol, the protocol will communicate. Bigger networks where you want dynamically something to happen, automatically something to happen, you must configure protocol and you must calculate the bandwidth. What will happen? I told you R1 is sending data to fail out to R2, correct? Now R1 is not failing, only ISP is failing. Understand?
Correct.
How you will change the state priority number, priority value. You remember in BGP, in STP, we studied this root bridge election, right? there is a priority number for that. So every time when you want to do any election process, we use some priority numbers.
Acha. Okay. Okay.
So here the priority number is 100. So what I'm going to do is in this priority, I am going to, but if you reduce this priority value, whoever is the higher priority, they'll be automatically become active.
So I mean,
100, okay? No problem. 100, no problem. Now I made one router 90. Then whoever is higher now.
so when it come back 100, how the ISP2 converts to ISP1 then?
So there are different techniques are there. You can change the value 10, 10, reduce the value 20, 20, something like that. So many options are there. But all are tweaking the tool, tweaking the protocol, okay? Fine tuning the protocol. But this is called FHRP. FHRP is clear?
Yes, yes.
Okay, so this is the FHRP.
Yes.
Okay, tomorrow we'll do the lab and we can cover NAT theory and lab. Compound house, big house, compound wall is there. This is the center house, your house, that's a compound wall. And in the house, there is a center location and there is a big party going to happen in your house. Okay. You are going to put some security for that. And in the security, you are going to give a list. In this list, you are saying who is permitted to this party, who is not permitted to this party. Understand? Who is permit inside this house for this party. Both lists are created from the center. I sat and wrote, take a paper, A4 sheet, I started writing. लिख लिया कौन कौन allowed है कौन कौन allowed नहीं है, right? I created. Do you understand the point? What I'm trying to say here?
Yeah, understood.
So this is the analogy. Remember this analogy. Now from the back gate, Amitabh Bachchan wants to go out. For example, the security will allow or not, Amitabh. Understand, no? What I'm trying to say. So the idea here is very simple. What is ACL? If anybody asks you, I'm going to create a list, okay? In that list, what will be there? Permit this IP address, deny this IP address, permit this IP address, deny this IP address. Understand?
Okay.
You got it or not?
Yeah.
So this is whoever is not there in the list, they are all by default what we call implicit deny. What is this word?
Implicit.
What is implicit deny? Whoever is not there in the list, they are by default they are denied. Understand? For example, I say permit 10.2, 10.3 is coming. It will not allow. Global mode. You can use any type of ACL, standard ACL, extended ACL, number ACL, named ACL. Like I gave number to ACL, no ACL 1, ACL 2. Same you can give name for the ACL. ACL HR, ACL sales, ACL IT, you know, you can give name also. So different types of ACLs you can create. Now, after creating the ACL in the global mode, you have to assign the ACL. Rahul is what? Inbound or outbound?
No, it's inbound.
Correct. So Rahul is inbound. So for example, you consider this is a router, right? Yeah. Now a package is coming to gigabit 0.0.0. That traffic what we call is inbound traffic. Okay, traffic is going out from router to outside. That traffic we call it as outbound traffic. Okay, understood, right?
Yes.
Now when you're configuring a ACL, you have to say to the router, incoming traffic is there, no? There you apply this. There you apply this. Okay. Firewall is different, router is different. Router connects LAN WAN. Okay? LAN WAN connector. Firewall divides trusted and untrusted zone. ACL and firewall. Firewall and router. Router function is to connect LAN WAN connectivity, different networks connectivity. Understand? Yeah, so there is a different purpose of each device, okay? Firewall is a security device. Router is a WAN connectivity device.
Correct. Okay.
Firewall is a security device, understand?
Right. Understood.
The nature of the firewall is to divide the trusted and untrusted zone.
Untrusted.
So that function is not done by router. Router connects the LAN and WAN, finds the best route.
बरोबर ठीक आहे.
Okay, so that is the purpose of difference between router and firewall. But
Correct.
what I'm teaching now is ACL, list of permitted deny statements, and how to create ACL in router. In CCNA we don't learn firewall ACL. In CCNA we'll study, but the concepts are same. In CCNA we'll study how to configure ACL in router.
Yes.
Okay, but as I told you, this is an IP service. The IP service can be used for any IP devices. Not only firewall, any IP devices. There's no much lab in there. Yeah. Security, we have some lab called L2 Security AAA that I'll show you that. Then I will start NAT area lab and DNS, all these things. So day after tomorrow, when you create standard ACL, you just what you write. You write only one IP, source IP address. That's all. Now, what is extended ACL is? It's a very detailed statement. For example, extended means I can say source IP, destination IP address, source port number, destination port number, and the different source protocol, that protocol, this protocol. All these things I can go that extent. There is only named ACL is allowed. There is no numbered ACLs. Understand? Only named ACL is allowed. Understood?
Yeah.
IPv6. This is clear, right?
Yes.
So tomorrow we are going to do the lab. The lab topology is this one only. This is the same topology.
Sir, so basically, before winding up, can you share some link for questionnaire on CCNA? The questions answer. I mean, what
I
are the?
shared no already. I already shared in the questionnaires in the Google Drive, right?
No, I didn't. I mean, when in which class you had shared? It was
In the Google Drive.
Acha, it's already there or what?
Let me just let me open the drive and see.
Because
Are you able to see? First of all, you tell me, are you able to access the drive?
I am able to access the drive.